Welcome back to the Explainer. So let's just dive right into this, because today we're tackling something that really bridges the gap between writing great code and actually knowing how that code performs out there in the real world. We're going to demystify custom metric instrumentation. And honestly, if you've ever stared at a monitoring dashboard and thought, how exactly do those numbers get there? Or more importantly, how do I choose the right way to measure my own app's performance? Well, you are in exactly the right place.
Okay, here's our game plan for today. First, we'll look at the observability gap, then metrics as data types. From there, we'll break down the big three: counters, gauges, and histograms. And finally, we'll wrap up with instrumenting your app. Simple, logical flow. Let's get to it.
Section 1. The observability gap. It's really easy to just assume that if your DevOps or site reliability engineering team has set up this massive, state-of-the-art monitoring stack, your job as a developer is basically done. But consider this idea, which is really the central thesis of the guide we're looking at today. Observability is a collective responsibility. It's a shared duty. You can have incredible tools like Grafana or Jaeger humming along perfectly, but at the end of the day, developers are the ones writing the applications. If you aren't actively emitting metrics from within that application, the whole system is effectively flying blind.
Seriously, think about this for a second. What is the actual point of having a powerhouse tool like Prometheus if the apps themselves don't emit any metrics? It's literally like buying a top-tier security system and then just forgetting to plug in the cameras. If your app isn't defining the traces, that massive infrastructure is just sitting there doing nothing. Building the stack, yeah, that's really only half the battle. Now you might be thinking, well, hold on, we use exporters. And sure, exporters are fantastic plugins. Something like a Node exporter is great for gathering general node data, telling you the CPU or memory utilization of your Kubernetes nodes. But here's the catch. Here's the crucial limitation. They cannot track application-specific metrics. A Node exporter absolutely cannot tell you how many users logged into your specific e-commerce app over the last 30 days. It can't tell you the HTTP request duration for a checkout service. That is exactly where custom instrumentation comes in. Writing those metrics directly into your code is the only way to bridge this gap.
Section 2. Metrics as data types. I absolutely love this concept because it bridges the abstract so perfectly. So, think about your standard programming data types. If you're coding in Python or Node.js, you've got your strings, your lists, your dictionaries, right? You don't just pick one at random. You choose the data type based on the actual nature of the data you're representing. You'd never use a string when you clearly need a list. Well, metric types work with that exact same logic. You can't represent every metric the same way. You have to choose the right metric type based on how the data you are tracking actually behaves.
Section 3. Counters.
Let's start with the simplest, most common type out there, the counter. The absolute key phrase to lock in here is only going up. By definition, a counter is a metric type for tracking a value that is always incrementing. It can never, ever go down. To really road test this in your head, just ask yourself, can a total login count ever go down? No, never. If a user logs in, that event happened. Even if they immediately log out or totally delete their account a week later, the total count of logins over that period still goes up by 1. Tomorrow it might be 2, the next day 5. It just keeps climbing.
So what does this look like in the real world? Total user logins in the last 30 days, the number of accounts created, the total HTTP requests your app has received. All of these represent permanent events. Once that request is received, boom, it's received. The number goes up. Bottom line, whenever you're dealing with a cumulative total, you're going to reach for a counter.
Section 4. Gauges. But what happens when your data doesn't act like a cumulative total? Well, that is where gauges come in. A gauge is your go-to metric type for values that can increment and decrement over time. It's basically a snapshot of a current state. This is a really clear contrast to the counter's one-way street. Think of it exactly like the speedometer in your car. It goes up when you hit the gas, and it comes right back down when you brake.
What's cool here is how this grounds those abstract concepts in everyday operations. Take CPU or memory utilization percentages. At say 11 a.m., your CPU might be running super hot, maybe 67%. But by 11:15, traffic drops off and it cools down to 50%. Up and down. The number of active config maps in your cluster operates exactly the same way. So if you need to track a value that naturally fluctuates throughout the day, the gauge is absolutely your metric.
Section 5. Histograms. Okay, so we've got counters for things going up and gauges for things going up and down, but there is a third and honestly often misunderstood type. Let's look at the classic manager scenario to see why we need it.
Picture this. Your manager walks over, looking pretty stressed, and asks, how many times did our HTTP requests take less than 5 milliseconds or more than 100 milliseconds? Now think about our first two types. A counter just says, here's how many requests happened. A gauge says, here's how long the current request is taking. Neither of those answers the manager's question about distribution over time. You need a way to literally sort this data as it arrives. And to do that, we build time buckets. Think about it like sorting incoming mail. We define specific buckets, a 5 millisecond bucket, a 10 millisecond bucket, a 100 millisecond bucket. When request A comes in and takes, say, 3 milliseconds to process, we drop it right into that 5ms bucket. If request B drags on for 85 milliseconds, boom, it gets sorted into the 100ms bucket. As your app is running, it is continuously sorting those incoming request durations into these predefined categories. So when your manager asks for that data, you literally just hand them the buckets.
Which brings us to our working definition. A histogram is a metric type that sorts tracking information about duration or latency into predefined buckets. It is absolutely the best mental model for tracking the speed and performance spread of your application. You are quite literally tossing latency measurements into different bins so you can easily analyze the distribution later on.
Section 6. Instrumenting your app.
All right, we've covered the what and the why of our three main metric types. Now, let's see how this all comes together in an end-to-end journey. It's really a simple three-step process. Step 1, like we've been talking about, is actually instrumenting the application code. You instantiate a client in your Node.js or Python app, you define your counters and histograms, and you expose a metrics endpoint. Step 2 is making sure your observability stack, like Prometheus, is installed and running. But Step 3 is the absolute glue: service discovery. In a massive Kubernetes cluster with 100 different applications running, Prometheus doesn't just magically know where your specific custom metrics live. You have to configure a service monitor to explicitly tell Prometheus, hey, look at this specific service and scrape the data from this exact endpoint. Without that final service discovery step, your beautifully instrumented metrics, they're never going to be seen.
And that's the crucial takeaway here. Custom instrumentation gives you the power to define exactly what matters to your application's health. We've explored counters for totals, gauges for fluctuations, and histograms for sorting speeds. But I'm going to leave you with this final thought. You've built the buckets, but what critical insights are slipping through the cracks right now because you simply aren't tracking them yet? Take a look at your own code bases this week and ask yourself what invisible data you could finally bring to light. Thanks so much for joining me on The Explainer today. I really hope this guide makes your next observability project a whole lot clearer.